Hi students, in this video we're going to cover lesson 3.2, angle equations and parallel lines. So our objectives are to review the angle relationships for parallel lines, and then we're going to use algebra to solve the equations with angles made with parallel lines. So a quick recap are these 5 relationships that we covered in lesson 3.1. If 2 lines are parallel, then corresponding angles are congruent. If 2 lines are parallel, then alternate interior angles are congruent. And you can read 3 through 5. It's the same relationship. Alternate exterior angles are congruent. Consecutive interior angles are supplementary. And consecutive exterior angles are also supplementary. In the next few slides, we're going to look at diagrams that refresh these concepts. So first, we have corresponding angles. That's going to mean, let's make a note. We're going to say same relationship to the intersection. That's an easier way to think about if you have corresponding angles. So the intersection for the 2 lines is like what I'm marking in red, probably not the greatest color to use. Let's use blue instead. So the 2 lines intersect here and they intersect here. And we can see that both angle A and angle B are above and to the right of the intersection. So we have above the horizontal line and to the right of the slanted line. So they're in the same relationship. They have the same relationship to the intersection. They're above and to the right. That's what makes corresponding angles. Same relationship to the intersection. Alternate interior angles we know are between a pair of parallel lines and they're interior, that they're on opposite sides of the transversal. Another way to verify this is the angles are inside of a Z. So if we look at angle A and B, they form a Z shape if we trace the lines. So that can be a forward Z or a backward Z, which I guess theoretically is some sort of S. So in between the lines, you form a Z. That's how you know you have alternate interior angles. Alternate exterior angles, you see that we have this GIF actually. The purple angles are a set of alternate exterior angles. The green angles are another set. So alternate exterior angles are outside of the parallel lines and they're on opposite sides of the transversal. Consecutive interior angles we said are supplementary. So we'll label this as 1. So we have set 1 that I just marked with 1s. Consecutive interior angles are supplementary, which means they add to equal 180. 116 plus 64 is 180. And then we have this second pair of consecutive interior angles. They are also supplementary, and we get 64 plus 116 is 180. We have consecutive exterior angles where the 2 angles that are blue are consecutive exterior angles. They are also supplementary, 132. So 132 plus 48, that's going to be 180. And then we have this other 132 right here, and this other one, and this other 48 that is also 180 degrees. And so consecutive exterior angles also supplementary. And so now we're going to work with algebra with parallel lines. In the previous lesson, we used parallel lines to find the missing angle value by determining a relationship. We are abbreviating. AIA is alternate interior angles. AEA is alternate exterior angles. CIA is consecutive interior angles. CEA is consecutive exterior angles. And just CA is corresponding angles. We can use these relationships to make algebraic equations that we can solve. For each of these, we're going to state the relationship, label our diagram, set up an equation to solve, and we're going to substitute our answer to verify our solution. So if you want to, you can practice, you can pause, practice, and come back and check your answer. So for number 1, given that line M is parallel to line N, find the value of X. So first, we're going to mark our lines as parallel. Remember, we just used the same number of arrow marks to verify that. So M is parallel to N. And in this case, we have a pair of corresponding angles. So the relationship we're going to say is corresponding. We have corresponding angles. We labeled our diagram. We marked the angles congruent. And now we can set up our equation. We get 6x plus 3 equals 7x minus 19. And then say we subtract 6x from both sides, we get 3 equals x minus 19. Then we add 19 to both sides, so plus 19 and plus 19 is going to give us 22 equals x. Don't stop there. Substitute your value in to make sure it makes sense. And so now we're going to get 6 times 22 plus 3. That's 132 plus 3, which gives us 135 degrees. And then over here we have 7 times 22. That is 154. So 154 minus 19 is 135 degrees. So that is how we know our answer is correct. Our corresponding angles are congruent. For the second example, we are still given that M is parallel to N, and we need to find the value of X. We're going to mark our lines as parallel. And then we have, in this case, same side exterior angles or consecutive exterior angles, however you want to think about that. Same side exterior angles are supplementary. So that means our equation, let's write this down. So same side exterior, and we call these consecutive exterior earlier in the PowerPoint. So same side or consecutive exterior angles are supplementary. So our equation is 7x plus 7 plus 2x plus 2 equals 180 degrees. So we get 9x plus 9 equals 180. And then we subtract 9 from both sides. And we get 9x equals 171. If you divide both sides by 9, you get x equals 19, I believe. Oh, let's go back. I'm sorry. So x equals 19. So it says find the value of x, but I encourage you to actually check your work. So if we substitute in 19, we get 7 times 19 is 133 plus 7 is going to give us 140 degrees. And x is 19. Yeah. So then if we substitute in 19 at the bottom, we get 2 times 19 plus 2. That's 38 plus 2, which is 40 degrees. So 140 plus 40 is 180. So our consecutive exterior angles are supplementary, or our same side exterior angles are supplementary. So that's how we know our work is correct. The next two examples come directly from Khan Academy. We have angle A is 5x minus 18. Angle B is 3x plus 42. We're going to find the value of those two angles. So in this case, we have angles that form a Z. They're the angles in our Z. So that's going to mean that they are alternate interior angles. So we have alternate interior angles, and alternate interior angles are congruent. So our equation is 5x minus 18 equals 3x plus 42. If we subtract 3x from both sides, we get 2x minus 18 equals 42. We would add 18 to both sides. We get 2x equals 60, and then divide both sides by 2. We get x equals 30. So if x is 30, you should again go back and substitute that value in to make sure the relationship is verified by numerical values. So we get 5 times 30 minus 18. That is 150 minus 18, which is 132 degrees. And then 3 times 30, which is 90, plus 42 is also 132 degrees. So because both of our alternate interior angles are 132, that makes sense. Also, if you look at the angles, 132 is an obtuse angle, and the angles that we have drawn look to be obtuse. So that's another way of verifying that our answer is correct. For example 4, it's another example from the Khan Academy. We have angle A is 6x minus 18. Angle B is 14x plus 38. We know the lines are parallel because we have these markings to indicate they're parallel. And in this case, our angles are on the same side of the transversal and between the two lines that are parallel. So this is going to be same side interior. So same side interior angles. Same side interior angles are supplementary, which means that 6x minus 18 plus 14x plus 38 is equal to 180 degrees. So if we combine like terms on the left, we get 20x plus 20 equals 180. Next, we subtract 20 from both sides, and we get 20x equals 160. Then we divide both sides by 20, and we get x equals 8. So again, you should not stop with x equals 8 because when you solve an equation, you always get a number. You should go back and verify that their value makes what you know to be true actually true. So then we get 6 times 8, which is 48, minus 18. That is going to equal 30 degrees. And then we substitute in 8 for the other angle. We have 14 times 8, which is 112. And 112 plus 38 is 150 degrees. So since we have same side interior angles, it should be true that 30 plus 150 is 180. And that is indeed correct. So that's how we know x equals 8 is actually the right value. And our last example is we have this diagram where we actually don't have a relationship between the two angles. These aren't alternate interior, alternate exterior, corresponding, consecutive interior, or consecutive exterior angles. So what we do know is M is parallel to N. So if line M is parallel to N, it means that corresponding angles are congruent. So the angle that corresponds to 6x minus 5 down here is this angle. So this angle is also 6x minus 5. In a previous video, we covered a linear pair. A linear pair forms a straight angle. And so now we have these two angles that form a straight angle, which means that 7x minus 10 plus, all right, I shouldn't work that right here. I should work it over here. So 7x minus 10 plus 6x minus 5 equals 180. And that's going, so 7, yeah. So now we're going to get 13x minus 15 equals 180. We add 15 to both sides, so we get 13x equals 195. You divide both sides by 13. Let's see, 13 goes into that 10 times, then you got 65 left over. So let's go with 15. So x equals 15. Let's actually make sure that's right. 15 times 13 is 5. Get a 1, you get a 6, bring down a 0, you get a 3. Yeah, 195. All right. So we get 195. So x equals 15. And, oh, let's take that back. Oh, let's go backwards. Excuse me. I'm not sure what's happening right now. All right. So we have our pen. So x equals 15. So now you should again go back and substitute in 15. So you get 7 times 15, which is 105, minus 10 is going to be 95. And then you substitute in 15 for the other angle. You get 6 times 15, which is 90, minus 5 is going to be 85. And we'll look at that. 95 plus 85 is 180. And so we get a linear pair. And that's, again, how we know our work is correct. All right, so that's going to conclude this video for angle equations with parallel lines. So we didn't do anything new. We just took our knowledge a step further, used the relationship that we had between the angles to justify an equation. We solved that equation and substituted our values back in to check to make sure our answer was correct.